Our next session is about University of Arizona support for desert ag research. What support can you find there? What resources does the university bring to help build these partnerships and to help build research programs? We've got two really key people in that up here. One is Parker Antin, first one to my right. He's the Associate Dean for Research and the Associate Vice President of Agriculture, Life, and Veterinary Sciences and Cooperative Extension. Parker truly has been an incredible partner in the growth of YCEDA and the research opportunity and helping with research opportunities. But yeah, Parker's brought a lot of research opportunities to us, helped us find resources, and even matches our small grants research program, which the researchers will want to take note. Ignore the lights. We have sound, that's what counts, right? Researchers will want to take note that we do have a small grants research program, and Parker's part of matching on that. The other one to my right is Dr. Mark Van Dyke. He's the Associate Dean for Research from the College of Engineering. So like Shane said, it's neat to see the recognition throughout the university beyond just the College of Agriculture of the opportunities here and the need here. I really appreciate that he's here. He's worked with us to integrate ag technology into some large grant opportunities and is currently doing so. With that, I'm sure we'll hear about that, but I do appreciate, Mark, your being here and being interested in this. So with that, I'm going to turn it over first to Parker to talk about resources from U of A helping to build collaborations and research programs.
Yeah, so I'm going to spend a few minutes. Where's Stephanie? First of my 46 slides. I'm just kidding, Stephanie. And tell you a little bit about the university support for research and how that translates into partnerships. And I'm going to tell you about 4 basic areas. The first is people. First and foremost, our most important asset, the one we covet the most, we encourage and we support the most. Then research investments from ALFC, the division. I'll tell you a little bit about what the division is. Then university support, and just very briefly about some international partnerships. So when we think about, on the academic side, when we think about faculty, we look at our academic units. And we have 10 academic units in the College of Agriculture and Life Sciences, 5 departments and 5 schools. Schools are a little bit bigger, more complex, tend to have multiple missions. And when we think traditionally about agriculture, of course, we think about animal and comparative biomedical sciences, which is animal sciences, and then biomedical sciences and plant sciences. And certainly those are the traditional areas that we have think about historically for investments in agriculture. But of course, we have more than that. We also have biosystems engineering on the left and entomology, which come in a very strong way and partner with our traditional agriculture disciplines, particularly for biosystems engineering, which is a joint department with the College of Engineering. Very excited about that. That's where ag technology comes in, and we're looking for some very exciting investments in that area that I'll tell you about in a few minutes. But what's really interesting over the last decade or so, and certainly since I've been here in this position since 2014, is this notion of convergence science. This is the idea that, of course, any of the grand challenges we have, we need to be bringing disciplines together to come to bear because they are complex problems. That's why they are grand challenges. And NSF a few years ago put out the 10 big ideas, and one of them was the grand challenges of today, protecting human health, understanding food, energy, water nexus will not be solved by one discipline alone. They require convergence, the merging of ideas, approaches, technologies from wide, diverse fields of knowledge to stimulate innovation and discovery. And we have taken that to heart for agriculture writ large to create investments in additional areas, and particularly in environmental science. So if we think about environment as part of agriculture, we suddenly realize that when we look at the schools, we have much of the college actually embraced, and certainly environmental science, natural resources and the environment, and also nutritional sciences and wellness as we make a somewhat bigger umbrella and think about the totality of what we need to bring to bear in agricultural sciences. If you take the more human aspects, for instance, in agriculture resource economics, ag ed, and even in human ecology and behavior, we can see that we've really embraced the entire college when we think about agriculture writ large. But what does this actually look like in terms of environmental science when we get down to people? Well, 3 examples. Laura Meredith in the School of Natural Resources and the Environment is a microbial ecologist. She works in the environmental science. She was the director of the rainforest at the Biosphere 2, did a landmark study in carbon movement through the ecosystem, studies volatile compounds coming off microbiomes in soil. She's now, with seed funding from the university, from the college, is now working in agriculture, actually under the gantry in Maricopa. Betsy Arnold, who's here today, I believe, is a world expert in fungi, and she told me it can be fungi or fungi last night. Is that right? Thank you very much. I like fungi. She is a world expert in that. I think she might tell her story, I'm not sure, but a long time ago she wanted nothing to do with industry. She was a hardcore scientist and then got involved with a very exciting company, and now she's a card-carrying industry collaborator and very exciting, and very much into agroecosystems. You can't read this, but it's on her webpage, and it's the defining aspects of her research, which are ecology and evolution of plant and lichen microbiomes, with a focus on fungal symbiosis and in wild and agroecosystems. So that's really exciting. So she's also coming into and embracing the agricultural area. Finally, Joey Blankenship, who's also here, is a soil biogeochemist. He's very interested in soil remediation. How do we bring soils back? How do we maintain healthy soils? And he's going to speak, I think, briefly later on today. So this is an example in the human aspect of how we actually are bringing many different disciplines together to come to bear on the issues related to agriculture. Investments and partnerships. So in terms of this, I just wanted to tell you very briefly that the College of Agriculture and Life Sciences lives in a larger division called ALVSI. Just so you know, it's a crazy acronym. But it also includes research infrastructure of the Experiment Station and Cooperative Extension. These all derive from the land grant acts in the and early 1900s that developed these. And what's important about these 3 is that there are resources that actually have come down from those, that come from the land grant acts and federal capacity funding. And this funding moves from formulas in the federal government to Cooperative Extension and the Arizona Experiment Station and the College of Agriculture and Life Sciences. We heard Charlie Sanchez talk a little bit about issues with budgets and how we've had fairly relentless budget cuts over the years. And one of the things that happened with these funds, which were meant to stimulate research infrastructure and research, was that it got sidetracked in the 2000s to keep people employed. And that meant it went to faculty salaries so we could keep other types of people employed. With the college doing quite well under Shane's leadership, we've gotten out of debt, we've moved forward, we have money now, we have lots of resources. The very exciting point about this is we are extracting that money out of faculty salaries and we are bringing it to bear once again on research projects and research infrastructure. And we're talking about $2.5 million a year. Okay, so we have very exciting opportunities here to use this money. How are we using it? Well, one of the ways is in innovation grants. We call this the IVIP program, which funds novel and potentially transformative research. It is up to $90,000 a year. This is a real grant. We're not talking $5,000, 6 to 24 months in any area of the college. Now, before we were able to extract money out of this, I was able to fund maybe 2 of these a year. This last year, we funded 13 projects for almost $1 million. Okay? So this is just an example how we are bringing this money to bear directly on problems. What kind of projects are there? Well, this past cycle, we funded 3 example projects that have direct relationship to agriculture. Damankar Sanyal, who's here, I believe, Damankar is funded to do the Healthy Soil Initiative, which is bringing the first comprehensive soil health assessment to agriculture across the state. Craig Rasmussen in Environmental Science is Enhanced Weathering and Soil Carbon Sequestration in Arizona Agricultural Systems, looking at scalable climate change systems. And finally, Gagi Davidowitz, a modular integrated agricultural system. You'll notice none of these are in plant sciences or animal sciences or biomedical ACBS, right? These are all about that convergence concept. This money is available every year, and I hope to see very exciting projects come from it. Just want a quick shout out in the Desert in Yuma Center of Excellence. You've already heard that we also partner and match their small grants program. Centers and institutes is another place that we invest heavily, and we're bringing some of those federal capacity funds to bear on those. One of them, of course, is YCEDA. We've heard about it, the poster trail of a public-private partnership. We've been very excited to support YCEDA since its launch. We're continuing to support it, and we're looking forward to ramping up that support because it's such an exciting and successful enterprise. Also, you may know about CEAC, the UA Controlled Environment Center, world-class controlled environment agriculture center, which we are very excited has been around since 1998 based upon a legislative action by the state government. We are supporting it very, very heavily, and we intend to continue to do so. Lastly, a new center called ARID, Agro-Ecosystem Research in the Desert. This is headed up by Duke Pauly. This is going to become reality early next year. This is bringing to bear this concept of agro-ecosystems, that agriculture is actually a highly disturbed ecosystem. And when you think about agriculture in that context, you bring a lot to bear, just as this idea of convergent science. This is an example of convergent science coming to bear in a variety of ways, and this one's, I think, going to be really exciting moving forward. Finally, I just want to mention some internal funding. The university does have internal funding opportunities, and some of those have been going to agriculture-related areas. Finally, international partnerships. So we are also moving forward in areas that create partnerships around the world. If you notice this band here, where all of these different institutes here are, it's in that arid band, right? So we're looking at partnerships, for instance, in Morocco at a university called UM6P, in Saudi Arabia with KAUST, in China, Northwest ANF University, where we have a micro-campus, and also, interestingly enough, in Kazakhstan, because the issues that these areas have are common to ours, and it's all about arid agriculture in arid lands. And so we're very excited to be able to create those partnerships because we see them, by having that synergy across these institutions, we see we can bring much far increased resources to bear on the problems that affect us right here in Yuma and in Arizona. So with that, I'm going to stop and I think turn it over to Mark, who's going to tell you about a really exciting new project.
So Parker and I are working on, and CALS and engineering are leading an effort in what is called the National Science Foundation Regional Innovation Engines. If you haven't heard about these, this is a game changer. This is the largest center-type program that the National Science Foundation has done in its history. NSF engines, Type 2 engines, represents a 10-year, $160 million funding opportunity. And as I mentioned, it's the lead. Each institution is allowed one lead proposal. The lead proposal for the University of Arizona is a partnership between CALS and engineering in agricultural technology domain. NSF engines is the most economic development leaning thing that the National Science Foundation has ever done. And what I mean by that is it's giving us an opportunity, because of its size, because of its scope, because of the prestige associated with winning one of these awards, to push a land-grant institution like the University of Arizona and our academic partners into more of an economic development posture than you will probably ever see. So that should be music to everybody's ears in this room. So I want to talk a little bit about this, and then we'll do some Q&A. So the theme for this, and the title for it, is called Climate Resilience in the Colorado River Basin States Engine, or we're calling it Crisis Engine. The topic area is the urgent need for scalable innovation in food and energy production with sustainable water management. NSF asked us to define a region of service, and we've partnered in the Southwest region. So our partners include the land-grant institutions in obviously Arizona, New Mexico, Utah, Nevada, and California. So that's New Mexico State, Utah State, University of Nevada, Reno, and UC Davis. The purpose and vision of this engine is innovation in the agricultural sector, which we all know uses over 70% of the water resources. And what we're trying to do is create a network of networks that creates very large impact. What NSF Engines is allowing us to do is to really reinvestigate the role of a land-grant institution. It was mentioned just in the last session about this tension between publications and industry-sponsored research, et cetera. NSF Engines is allowing us to have conversations about things like how do we motivate faculty who are focused on scholarly publications to actually engage in use and user-inspired research. How do we do technology transfer for better? How do we create entrepreneurship or an entrepreneurial mindset among faculty, students, and the community? How do we address workforce development in ways that focus on brain drain from rural communities, et cetera? So it's a really, really exciting opportunity, and at a level where we have visibility with university leadership that you don't get with smaller projects. So again, this is the region of service, focus on the Colorado River lower basin. It was born out of, and Shane mentioned this morning, an effort that we took on last year, a funding opportunity that came out of the Economic Development Administration, EDA's Build Back Better Regional Challenge. We built a coalition across southern Arizona that included all of these partners, and you could see Greater Yuma, and YCEDA was engaged in that as well. We got a lot of support from Paul. That effort resulted in a successful Phase 1 award, a planning grant of $500,000. And so the work of this coalition, Southern Arizona Coalition for Climate Adaptation and Resilience, or SACAR, has been instrumental in the building block for what we're doing with NSF Engines. So this was the initial model and where we started from. And what we're doing is taking this model and expanding it throughout the Southwest region, trying to create this network of networks. What do we need? As I said, we're having a lot of internal conversations about things that I imagined would have taken a lot longer. So thank goodness for NSF Engines. It's giving us an opportunity to push our leadership toward this posture of economic development like I've never seen before in my 20-year career in academia. We're in the throes of the grant application right now. It's due in early January. There's a lot of writing, a lot of planning that's going on, a lot of budget preparation, et cetera. What do we need from this group? What is the message that I'm here to deliver to you all? We need industry engagement. We're going to do the work on the faculty side. We've got to improve the value proposition to our faculty to engage in this kind of research. But we really need community level involvement and industry level involvement. There's a whole variety of ways that industry will be involved in this engine when we do win it. The lift for the proposal is actually pretty light. We just actually need to have some conversations about what it is that we're trying to accomplish, what is the role of industry, and how you all can support this proposal effort, because what the NSF and the reviewers are going to be looking for is exactly what you guys have already built here. We're looking for YCEDA-like activity, YCEDA-like culture, and how do we bring that into a regional engine that runs for multiple decades with many, many millions of dollars invested in it. So I'm going to stop there 3 minutes early, and I hope you guys have a lot of questions about this. I know I went through it really fast.
All right, thank you. You know, we've talked a lot about industry. We've talked a lot about industry and their support and how key that is, but I do want to stress the support of the university has also been key to this, and these two gentlemen are two reasons for that. So are there any questions out there?
Hey guys, it's Shanna again. I can't not ask questions. Do you have extension involved in your NSF crisis, and how can we help you?
Yeah, very definitely. So the idea is, and Parker can talk more to this because he's sort of leading the charge, one of the big features of NSF engines is use and user-inspired research. And so this is why we've got to think about how the university does things differently. A lot of our research programs are initiated by the ideas that the faculty have, and that's what you're taught, and that's kind of how you're trained as a faculty member. And I can tell you this is very ingrained in the mindset of engineering. But what engines are about are use and user-inspired research. So we need those ideas coming from industry, coming from communities. Extension is the conduit for that, right? That's how we get those ideas back to main campus. That's how we get them to the ag centers and to the agricultural stations. That's how we get them to places like Yuma. That's how we work on them collectively as scientists and engineers, but also as practitioners. And then that's also how we push them back out, because technology transfer and that translation back into the use case, back into the market is going to be a huge part of NSF engines.
Yeah, and in fact, I think I'm on. The whole structure here is that there's going to be a diverse sort of advisory committee made of community stakeholders, regional stakeholders, industry, as well as university and technology transfer, who are going to identify important grand challenges, that technology challenges, and then bring them back to the university and say, who wants to work on them? So it's the exact opposite model we use now for technology transfer, which is stuff bubbles out of the faculty, and some of it might or might not be relevant. Okay.
Yeah, that's great. And I would suggest maybe as you're still putting the proposal together, engage industry, right? Like you're doing now, engage extension to help you get some of those concepts into that proposal before it's submitted, and that can help strengthen that.
Thank you, Chana. Any other questions?
Right, is the industry partnership, is that financial, or is it just that they want to participate with you guys?
Yeah, great question. I'm glad you asked that. We're not asking for a dime from industry. This is not the kind of project where what we're doing is saying, you know, here's a government project, we need industry matching dollars. Matching actually is not allowed in NSF programs. So roughly speaking, budget-wise, there's going to be, and I'm sort of shooting from the hip. Well, there's several features. So there's probably going to be a minimum of about $1.25 million just in seed projects that industry can initiate. There's going to be $10 million in a venture capital fund of NSF money, in addition to probably another $20 million coming from outside the NSF monies for small and startup companies. There's going to be another probably $10 million invested programmatically across the 10-year lifespan with the money that the NSF is putting in. And we're talking about substantive projects. Parker was mentioning, you know, he's not doing seed projects at $5,000. Seed projects are going to be kind of on the order of maybe some 50, 100K projects, but the flagship projects are going to be $750,000 projects. $160 million sounds like a lot of money. It is a lot of money. We're going to figure out how to get every dime of value that we can out of it. But this is not a case of, you know, we need industry matching money. We need the ideas. We need the challenges. We need the problems. We'll get it funded.
How many awards are anticipated?
5 in this first go round, which may, you know, who knows what the future will bring. There were 839 concept papers submitted for all Type 1 and Type 2 applications. We expect that there will be probably something like 150 Type 2 applications for the 10-year, $160 million. 5 awards out of that 150.
Yeah, and we expect that to be another round next year, correct?
Yeah.
This is the flagship research grant program for the new directorate at NSF called Technology, Innovation, and Partnerships, okay? And they're going to put in upwards of $1 billion, as near as I can tell, into this program.
But very competitive, hugely
If you're looking
competitive.
for industry collaboration, ideas, the creative juices and things like that to come up with guidance for where you're going to go with various projects, or what projects might apply to certain regions.
I see it a lot like YCEDA, right? Ideas coming from the world, coming from you all, that then we look for how we can bring human and physical capital to bear to solve them.
Yeah. Industry is going to help select the projects. There'll be a governance structure put in place. There'll be a scoring rubric. Faculty, we're going to take faculty outside their comfort zone. Faculty will be required to build projects that are industry relevant in this program.
So we're about out of time, but I want to hear from Bert's question.
This is Bert from Yuma Ag Center. And my question is, are you contemplating on this vision the opportunity for supporting infrastructure for the ag centers? Because this is going to be a heavy load.
Yeah, it's a great question. Unlike the EDA, which was very infrastructure heavy, NSF is not so much. We'll be able to put some in, but it's not as infrastructure intensive as the EDA Build Back Better regional challenge was. So I would say the answer is yes, but probably in a more modest way.
And Sonia's here. Stephanie, can you give Sonia the mic? She'll get the last question. We appreciate Western Growers being here.
Thank you. Very easy question. You said this will be needed to support regional needs. So are you contemplating specific states, the western states, other states? What is the scope of reach that you're thinking of?
Yeah, so our initial partners are the lower basin states, us, New Mexico, Nevada, California, and Utah. We're starting with the land grant institutions, right? We're the ones that have the mission in agriculture. But over time, and engines are going to be funded for a decade. They're expected to exist beyond that. Over that length of time, we expect that there will be many, many additional partners, and partners may come and go, but the anchors will be the flagship institution in those 5 states.
Okay, let's give them a hand. Thank you, guys.